Hi, my name is Andrew Brown, and this is a presentation for the MECH3302 Mechanisms for Mechanical Systems group project. For this project, I was tasked with designing a mechanism similar to the one that you can see here for opening a window. In this case, a casement window. So the window would be opening and sliding from the side and not a hinged or drawn window. Before we get to the design of the actual window itself, we'll talk a little bit about the background of basically window openers. So some classic window opener designs, we have a single hung window. This is very typical, very old-fashioned, where basically the window just slides up and down and something would be put in the window in order to prop it to keep it open. Now, some of the flaws with this design of window is that only half of the window can actually open, whether that's the bottom half or the top half, depending on the design, but you're still very, very limited. As well, there was no easy way to keep the window open. You literally had to just place a prop within the window to kind of store it in an open position. It was also hard to close as well. The other main design was a casement window, which is what the mechanism that we'll be talking about a little bit later is actually based around. And in this case, the window is typically hinged on the side, and it opens very similar to a door. That's how it would open. This design is much improved, where now you can have the entire window open. But at the same time, if the window is just hinged and it's very similar to a door, there is nothing to prevent the window from shutting, say if a breeze came by and blew it, or anything along those lines. Now, when we look at more modern window opener designs, there are many different variations and different types. There's also different types of ways to open a window, but we'll be sticking on just the ones that are very similar to the mechanism that we'll be designing today, which is based around a casement window. So when we're looking at a push-out casement window, we see that today's designs can typically be very complicated, very complex. They involve usually a lot of parts, and they're designed in such a way so that the window can open very easily, but at the same time not be blown shut by wind or something along those lines. We also have the opposite, which is something that's very, very simple, as you can see here in the second design, where there's not very many parts or mechanisms involved, and it's very simple, and it just would lock it into place there by holding the window open to whatever degree that the user wished. So we have a little bit of background knowledge on kind of what the window would require, kind of what typical designs are looking like. We'll talk a little bit about the methodology that was taken in order to develop the design for this project. So for a casement window, one of the more important designs for the mechanism itself that we were looking to create is an equation called the Chebyshev-Grubler-Kuchbach formula, which I'm sure I'm not pronouncing correctly, but it's very similar to that. Basically, all this formula is used for is for determining the mobility of the system, or how restricted of movement that the entire system of mechanisms is. So in this case, we can see the formula here, where the mobility of the system is determined by the order of the system, which in our case, because it's planar motion, that would be taken as 3. The number of links, so that's how many basically physical pieces are actually used in the mechanism itself. So the number of joints, so the number of joints per link can vary, and it's also determined by the type of joint that it is. And then we have the number of degree of freedom for the ith joint. So all that's referring to is basically how many degrees of freedom does each one of those joints have. And when we take this and we apply it to all the different links and joints that we come up with in our design, we determine a mobility of the system. Typically, the lower the mobility, the closer to 1, the easier it is to use, and it can also be operated by a single motion. So the other important element that's used for designing our casement window opener mechanism is the actual specifications of the window itself. We're kind of restricted in the dimensions that we could use. So in this case, we're just going to use very generic window dimensions. A very typical sized window in your average home, say in a living room, would have some dimensions around about 50 centimeters in width, and it may be about 2 centimeters in depth. Now you'll notice also that there is no height here, and that's because typically the height for this type of design that we're going with really doesn't matter. The only thing that would matter with the height is how heavy the window becomes and how strong the actual components themselves would be, but since that's not a requirement of this project, we're just going to temporarily kind of ignore it, and we'll just assume any height that we wish. So one of the other requirements that I put on this project personally myself was to make sure that the window must be able to open so that there's enough room for someone on the inside to be able to reach both surfaces of the glass. This is important because typically if you don't live on a ground floor or the window's not on a ground floor, it's very difficult to clean the outside of the window. And one of the advantages of this type of design is that it can be made so that way the window can actually slide in such a way so that a user from the inside could actually reach both sides of the glass in order to clean them. So that was very important towards the design aspect of this project. So starting to design the links that are going to be used after an initial sketch was done and some preliminary work, I first started to look at the very first link, which was going to be the one that's actually connected to the window itself at the base of the window. And this one was the easiest to design because I knew the length, I knew the size of the window, it was going to be 50 centimeters. But what's important here, you'll notice, is that the link length is actually different than the entire length of the piece. And that's simply because the link length is only determined from the distance from one joint to the next, because that's all that really matters. The rest of the length of this was just to simulate the full size of the window. So for the very first length, I chose the length of the window, which is 50 centimeters. And then as you'll see as the components start to come together, that the link length here of 105 millimeters is between the two joint holes that will connect to further elements of the design. So the second link that was chosen, link 2 here, once again has 100 millimeters in length, but only an 80 millimeter link length. This is the distance that the window is going to be from the actual ledge. So this was the second most important component, but also the second easiest component to design from dimensionally from that aspect, because it was pretty much determined by the size of the window itself. So then when we look at the third length, we have an effective length of 150 millimeters in total length, or sorry, total link length, not total length. And this one was another one of the easier elements in order to develop. We'll see at the end why when we look at the overall design. So now moving on to the fourth link. This one was probably the most difficult to design for them all, simply because it actually has 3 different joints on it. So there's a joint on either end, and then there's a joint very close to the middle. It's actually slightly offset. So you'll see that this actually has 2 different link lengths. The first link length on the left and then on the right are 2 different sizes, 150 millimeters and 225 millimeters. That's because there's 2 different elements that, 3 different elements that have to connect to this individual link, where the other ones we've seen so far only had 2 different links connecting to them. And this is actually considered the 5th link, but this is actually a slider bar. So it actually just slides within a slot, and then it has 2 of the links connected to it. So we actually have a link length of only 25 millimeters here, but then we have a travel distance. So this is how far that this piece is actually going to move within that slot that's going to be basically bolted to the window sill. So it's not, the slot itself doesn't move. And then when we see the base with the slot, this is the part that's bolted to the windowsill. This is where the slider bar is going to be inside of. And then you also see on the left-hand side, there's a hole there where one of the links is going to connect to that as well, which just kind of holds everything all together. So this is the total length. This is the width of the window, which is 50 centimeters. And then we have a slot length of 180 millimeters. So now that we have all the different components designed themselves, we can connect them all together so we can actually get a complete mechanism in order to open the window. So the first part of the mechanism is going to be in the closed position, so everything will stack up all nice and neat, as you can see here. And then once the window is actually in the fully open position, we can see it is here, and you can actually see the trace lines that'll show the path that the window is actually going to take as it's being opened. So now you can see each of the individual components, where link 1 is in blue, link 2 is in yellow, link 3 is in red, link 4 is gray, the slider bar is white, and then the base sill piece is black. So in summary, we have our final design, which can be seen here in the half open, half kind of closed position. And some of the notable pieces is that it's a very simple design. It only has 6 pieces. It does allow the user to reach both sides, which is one of the initial requirements that I put on this project. And that the window actually closes tight seal in the frame itself, so that way it doesn't hinge on the side, it actually slides and locks in. And when we look at our mobility equation, we can see that this has a mobility of 3, which is not ideal, but it does work well because of the way that the window works and it seals within the frame. It can't actually go back on itself. So now that we have the design, well, and we've kind of looked at it and developed it, we kind of looked and thought, well, what could be improved with this design? One of the first things is that we could change the number or the type of linkages used in order to reduce the mobility down closer to 1. That would be a great improvement. Second of all, we could replace that slider with a hand crank. So instead of having to push the window out, we could simply crank a handle and the window would move itself out. And lastly, we could motorize the entire operation and reduce the total number of linkages and just replace it with an electric motor to make it even easier for the user. So thank you for watching, and I'll leave you here with a short little video of the actual mechanism itself in action.